Hello. In this video, I'm going to demonstrate data for homework 2. So, uh, so homework 2 is also closely related to chapter 4, what we learned from chapter 4. So, this will be a nice review of chapter 4, and also we'll show you some new functions, new options you can use on Stata. So remember, by the way, I'm going to start from the very beginning. So some of what I do is already done in the first homework demonstration. So, but still, I'd like to just show you again until you got familiar with them. So first thing, when I open Stata, the first thing I usually do is to change the working directory. So now we are going to there are a lot of things. Teaching 420 homework number 2. Okay, so I changed my directory and I will open the data. So the data is already on the directory, on the folder, and of course you have to use your own folder, your own address of your own directory. So I loaded my data, and what I need here is birth weight, which is the newborn baby's birth weight, and smoker. Smoker is an indicator, a binary variable, whether the mother is a smoker or not. So if a smoking mom, then this variable takes 1, and for non-smoking moms, it takes 0. So 0 or 1. And homework 2 does not ask us to draw any picture, but let me just start with a scatter plot. Scatter plot was here, and you choose birth weight here, and you choose smoker here. Let's see how the data look like. The data is given by this, and it does not help that much because first, the smoker is 0 or 1. The variable smoker takes 0 or 1. So as I said, smoking mothers, non-smoking mothers. But the problem is there are a lot of observations on the same smaller area, so you cannot tell what's going on there. So it's hard to see where is the mean. Maybe somewhere here and maybe here. It's not easy to see what happened. And also another thing you may want to see here is think about the homoscedasticity. If homoscedasticity is true or not. So like it looks like the dispersion, the variance for non-smoking mothers is from here to here, up to here, this much, and the dispersion for smoking mothers is here. However, it is just like eyeballing. It's not an accurate analysis, but it looks like I'm not so sure. And maybe if you ignore these outliers, maybe they look like homoscedastic, but I'm not so sure. So conclusion is that when you have a binary regressor like this, whether 0 or 1, scatter plot does not help that much. Scatter plot is too much crowded at some points, so it's hard to see what happens here, and just look like a line, not points. So does not help. And we are going to now, so then instead of drawing the graph, I would like to calculate the mean and standard deviation and something like that. And a useful command is using summary. So summary and descriptive statistics function is here. So you can, if you use this function, simply it will return the basic summaries as it says. So birth weight, and then if you click this, okay, then the command is summarize birth weight. Intuitive. It summarizes the birth weight variable, and in the data there are 3,000 observations, 3,000 mothers, and the mean birth weight is 3,382, almost 83. So maybe it's in grams, I guess. And standard deviation is nearly 600. So you have approximately, you get ideas. So the mean is 3382, 33 and 82, and standard deviation is about 600. And the smallest baby, surprising, the smallest baby is only 400 grams. It's 1 pound, less than 1 pound. Oh, super surprising. And maximum is 5.7 kilograms, which is more than 10 pounds. I think my son was about 4 pounds at birth, so it's a surprising number. Okay, 4 pounds. No, not 4 pounds. 8 pounds, I think. I don't remember. Anyhow, so this is the summarize variable, and you don't need. You may include multiple variables and the same summarize command, and say, I am going to summarize 2 variables at the same time. So then you will get this result. The first line is the same about birth weight variable, and the second line is about smoker variable. Also, there are 3,000 observations, and its mean is 0.194. So in this case, as I said, smoker is 1 or 0. It is a binary variable, and it shows whether the mother is smoking or not. So it is not a number. And so even if it is coded as 0 and 1, it's not a number. And the mean should be interpreted as the probability of smoking. So from the data, approximately 19.4% of mothers are smoking during their pregnancy. And standard deviation is 0.39 something. And obviously minimum is 0, maximum is 1. It's meaningless. So this is the summarize command. It's clear and looks very useful. And what I'm going to do from now is that we are going to study the birth weight, distribution of the birth weight by each group. So we would like to calculate the the basic statistic summaries for smoking mothers, and then we would like to calculate that for non-smoking mothers. To do that, I'm going to go to here, and the same, we are going to study birth weight here, and go to this option. If you go to this option, I will type the condition that we are going to use. So remember, I'm using 2 equalities here because it is conditional logical equality. So I'm not defining the smoker variable equals to 1, but I'm checking whether smoker and 1 are the same or not. I'm comparing them. So when you compare 2 things, you have to use double equalities. So I will just show you what happens if you do not use 2 equalities. Then it will show you an error. So then, but still it gives you the syntax. So I'm going to copy this and use another equality. Then it works. Right? As you see, 1 equality does not work, but 2 equalities when you compare 2 things. 1 equality means definition. Anyhow, also, and there are 582 smoking mothers, and among them the average birth weight is 3.1 kilograms, which is smaller than the overall average. And standard deviation is 580. So that's what you get. And what we are going to do the same thing for the other group, non-smoking group. So change 1 to 0. If you change 1 to 0, then you will get a different summary. In this case, you have 2,400 non-smoking mothers, non-smoking moms, and their average birth weight is 3.4 kilograms, which is greater than this and also greater than the overall average. Standard error, standard deviation is 584. Now then, before looking at the average, you may compare the standard deviations. I think so. The difference is only 4 out of about like 600. So I think the standard deviation is pretty much constant across two groups. So in this case, you may argue that the model is homoskedastic. So homoskedasticity looks like it holds. Looks like to be true. So we used if command. You can use if command, if option to calculate summary for under a specific condition. Actually, there is an easier way to do that. I just showed you to show. I just did it this way to show you the if command. But an easier way, in this case, an easier method is to use summary statistics and by if. You may simply check this. Repeat the same command by groups. So if you're going to do the same command for all groups, you don't need to use the if command, but simply enter the variable you are going to use as a group. So then this is the command. So by smoker, the variable smoker, by smoker, comma, you are going to sort the results for each value of smoker, and then colon, and then summarize the birth weight variable. So it's a little more complicated, but still it's intuitive. By a certain variable, you are going to repeat the same thing from the smallest value to the largest value. So sort will be included. And the results are the same, 0 and 1, same thing. You may compare the results. Okay, let me go. I'm going to stop the video here, and I will finish. In the next video, I will show you the regression commands, and see you there. Bye.